How's it going, everybody? And welcome back to our Cisco Enterprise series. Excuse me. In this video, we are going to be kicking off the OSPF section of our series and with a high-level overview of the protocol and all the good stuff that goes along with it. So I'm going to start off with the overview, and then we're going to go through, like I said, with EIGRP. The goal with this introductory section is, or this beginning portion of OSPF is just to go through the main points, like to get you basically a CCNA level of understanding when it comes to how OSPF works. And then once we have our 4 routers and service provider 1 stood up and all that stuff squared away, then we have we've covered path selection, how OSPF works, standing up some adjacencies, doing some basic authentication, things like that. Then we'll focus on moving back over to the big HQ location, and we'll take a much more involved look at how OSPF will work. My goal, I was actually looking at it the other day, my goal initially was just to have, and up here I didn't actually lay out any specific routing protocol for the HQ location, but as I was looking at it, I was like, well, you know what? It probably would be a good idea to take EIGRP and do a whole EIGRP deep dive over here before I start doing things like DMVPN overlays with EIGRP and stuff like that. So that's probably what I'm going to do with EIGRP as well, because as far as I've gotten with it so far, because I'm actually recording EIGRP OSPF kind of concurrently, cover a couple of OSPF videos, a couple of EIGRP, things like that, and I'll go back and forth with the intention of getting the CCNA level stuff done so that I can build out the BGP piece, because before I can get into any of the more advanced routing designs for overlays with DMVPN, FlexVPN, that type of stuff, MPLS VPNs, I've got to get the underlay built for all the service providers. So that's what I'm planning on doing with that. So we're going to definitely be digging into EIGRP over here as well. We're going to be focusing on the switch 7, switch 8, switch 13, switch 14, and the core stuff. I'm not going to dive into any of the Nexus stuff right away, simply for the fact that they are resource intensive. And not that I'm really worried about resources. I've got plenty of compute level. I mean, I'm barely running anything right now, but give it a little bit of time. The CPU is going to spike, the memory is going to go up. So I've got 41 nodes currently running in the topology, and I'm running at 8% CPU. Or was that 8%? Between 6 and 10% CPU. So overall, the topology is not. I'm not stressing this server at all, really. So without any further ado, let's go ahead and dive into OSPF, and I will go ahead and get out of the way. I'll do a little bit of whiteboarding as we go along. Probably not a lot in this video, but I'm going to stop talking about what we're going to be doing and talk about what we're here to talk about. So OSPF, the Open Shortest Path First routing protocol. It is an open standards-based protocol. There are some really good recommended resources I'm going to give to you out of the gate, because OSPF is going to be much more involved and much more difficult in terms of a routing protocol to scale and to initially understand. So I definitely would recommend OSPF Anatomy of an Internet Routing Protocol, Routing TCP/IP Volume 1. Now, I'm a nerd, and because of the fact that I have spent the time to read through the config guides and the command references, watch the technical guides, read the technical guides. There's like an FAQ that you can go onto Cisco's website. Let's see if I can't find it real quick on here. Let me go over here to the Cisco OSPF FAQ. Frequently asked questions. Is this what I am referring to? Yes, here we go. So I've read through all of these. There's a bunch of questions, whole bunch of questions. And what they do is they literally will, as you go through this, Why are loopbacks advertised as /32 host routes? It's considered a host route in OSPF. Da 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 da. And so it goes into the details as to how that works. And so the idea is to go through, just Google the OSPF, Cisco OSPF FAQ. It's going to bring you to this free website or web page. And I would definitely recommend reading through all of this, because this is something that, how do I put this? You could potentially get a question on an exam that comes from this. Not saying you will. I can't, not saying that I have, but you never know when you might run into one of these obscure, like, like, can I control the P bit, the propagate bit, when I export external routes into a not so stubby area? When external routing information is imported at LSA type 7, to further distribute the LSA into type 5 LSA, the P bit is there to do all the translation of 7 to 5. Only those LSAs with the P bit set are translated. So you can do not advertise to fix that. Stuff like these are going to be some of, could potentially come, you could get an exam question that comes right from this FAQ. So things like that if you haven't read it, I would recommend going through it. So let me go ahead and close that out. So that's one thing I would definitely do. Like I said, I'm a nerd it's just who I am as a person. So I definitely would recommend, if you are looking to take OSPF beyond like a CCNA or a CCNP, I would definitely recommend reading the RFCs for both OSPF version 2 and version 3. And one thing I want to call out before we get into the meat and taters, as Jimmy Ray Purser would say, of the protocol, OSPF version 2 and OSPF version 3 are not compatible. So I learned, I don't remember when I learned this, but I remembered hearing this and going, huh. Like, it was like one of those light bulb moments where I was just like, I had never really thought about it. So I decided, I took a couple of routers that I already had running in a lab, and I stood up OSPF version 2 on one side and OSPF version 3 on the other side. I was looking at debugs on both sides, and nothing was happening. And it wasn't until I turned on, I think, V3 on the other side, and I started to get it to work. So V2 only does IPv4 unicast. V3 does address family IPv4 and address family IPv6. So that's one of those things where you'll have to be address family specific with your configuration. So it does both V4 and V6. So that's one of those things where you're just going to be cognizant of what it is the technology supports. So with that being said, I definitely would recommend, if you have, if you're planning on going, say, CCNP or higher, if you're looking to do, because the Encore exam is the new CCIE written exam. There is not a dedicated exam for that like there is for CCDE. Like another exam I'm studying for right now is there is no dedicated CCIE written. So the core exam for every track is your written exam, which is why I made mention a while back when the new exams came out, that the core is a good place to start with. But if you are serious about getting into potentially going after your CCIE in any particular track, is to at least learn all the different technologies that are on the concentration exams as well. So not saying that you have to go out and earn all the certifications, all the concentration, take them, pass them. I would definitely say to get your CCNP, you got to do at least one, right? But if you're, of the mindset, I know there's a lot of people studying for CCIE right now. I work with a couple of guys that are going after it, and I'm actively helping them, pursue their CCIEs, because I, for one, know how hard it is to pass. So it's one of those things where if you want to take it to that level, I definitely recommend reading the RFC. And that's going to be, there is no RFC per se for EIGRP because it is Cisco proprietary, but there are there is an RFC out there for it, but it's for the publicly released pieces of it. BGP, definitely read the RFC for that and all of the additional edits for it. And the reason why I say that is because it's an open standards protocol, right? So every vendor, if they want to use OSPF as their routing protocol, or a routing protocol their hardware supports, then that's something that they are going to dig into and have to understand, because Juniper and Cisco, if they're going to both deploy OSPF, they have to be able to be compatible with each other's hardware and their platforms. So, and I've set up OSPF and BGP between Cisco and Palo Alto thousands of times. So it's one of those things where, if you're going to be standing up a protocol, you had better get it, the vendor better know how the RFC is written to stand it up correctly. So that's one thing that I definitely recommend, is digging into the recommended resources and learning those technologies, because those sneaky little exam questions, excuse me, I remember, was it my second or third service provider written exam? I'm thinking back, it's been probably 4 or 5 years since I've taken an SP written exam. Or I'm sorry, because I sat for the exam in 2019 for the SP lab. I didn't pass, but before that, 2018 maybe. So where I'm going with that, there was a specific question that I remember on the exam being asked, and I had no idea how to answer it. And so I ended up, when I got home, and matter of fact, I hadn't even left the testing center yet when I pulled up my phone and I Googled it, and it pulled up right away, and it was, I won't give you the context of the question, but it was a BGP feature that I didn't even know was a thing. Even though I had read the majority of the configuration guide, I hadn't read that one little bookmark inside of the BGP config, because I was like, they're not going to ask about that. So you never know what they're going to ask you about. So just be cognizant of those things. All right. So with that being said, just to refresh that or review, OSPF v3 routes both v4 and v6. There is multi-address family support. That's what MAF stands for, is multi-address family. And then you have RFC 2328 as the OSPF version 2, RFC 5340 for OSPF v3. It is a classless link state protocol, meaning it does not pay attention, it doesn't do classful routing. So it does pay attention to the subnet mask, so the prefix and the mask. It uses the Dijkstra shortest path first algorithm, and it maintains active adjacencies. So there will be some scenarios where this will be a limit to design and traffic engineering, and we'll talk about that down the road when we get more into the weeds of how OSPF works. It does support variably length subnet masks, so /28, /22s, things like that do not fall inside of the classful range. It supports both topology and network layer reachability, or NLRI summarization. So you're going to hear the term NLRI when we get into BGP as well. And BGP, in my opinion, does a much better job of. We really shouldn't use the term NLRI with OSPF, because unlike all the IGPs, RIP, EIGRP, OSPF, IS to IS, there is no network advertisement from the IGPs, but there is from BGP. So we'll talk more about that in detail later, but essentially when an IGP forms an active adjacency with another dynamic routing protocol speaker, whatever that might be, what will end up happening is, because of the fact that you enabled the IGP on that particular interface because it matched the network statement that that interface had an IP address that matched on, you automatically are going to put that into your local database, and that's going to be an advertisable subnet that IGP is going to propagate for you. So where BGP doesn't do that. If you don't advertise anything to BGP, you can have as many control plane connections, whether they're full mesh, route reflected, whatever the case might be. You can stand up as many BGP peerings, whether they're internal or external, until your heart's content, until your fingers bleed, or until you're done clicking on the mouse buttons to try to get stuff to stand up. Until you start advertising something from BGP itself or doing redistribution of another protocol into BGP, it doesn't advertise anything. It simply forms a control plane peering, which is why I think network layer reachability information, NLRI, is a more applicable statement for BGP than it is for OSPF, but I digress. What it basically is doing is when you talk about topology and NLRI summarization, is the ability of doing inter area summarization, so internal summarization and external summarization. So where if I'm doing external summarization, I'm trying to control the amount of routes or what is being redistributed in, and I want to control those summary routes. That's going to be how that comes into play. When it comes guaranteed loop-free topology, all routers agree on an overall topology and the SPF for calculation. And essentially what this means is there's a database that OSPF has, the link state database. IS to IS has one as well. It's called the link state packet database because IS to IS is a different type of protocol, and it runs. The default protocol is IS to IS, integrated system to integrated system, where it's a layer 2 protocol, where it was, I use the term bastardized because of the way that they did it, but essentially the folks that wrote IS to IS and they wanted it to be able to route IP migrated it and they call it integrated IS to IS. So basically it can route layer 3 and it uses link state packets, LSPs. So it's a link state protocol just like OSPF. It uses the same calculation, SPF. So they're both extra shortest path first algorithms that do the route calculation for it. However, IS to IS does things a little bit differently. At a very, very high level, they're almost identical in how they do things. But from a very, very low level, the way that they do stuff is different enough to make IS to IS, in my opinion, actually a better protocol for scale. But we'll get back into that in another video. So the overall topology is you have the link state database, right? And every router in that area must agree on that database. If there is a diff between my database and your database, yes, an adjacency will still form, and we will do a full link state database exchange between ourselves. A database exchange will happen. So that information will still happen in the background. You won't actually see it in real time unless you're debugging or watching Wireshark. But that's as far as it will go. Because when SPF goes into play to calculate the best routes, it's going to notice a diff on one side and the other, and SPF won't run. So we'll talk about that more in detail when we get into that. And the most common thing that you're going to see that is when you have the wrong network type set on one side or the other versus broadcast versus non-broadcast multi-access or NBMA. And we'll talk about how that comes into play in a later video when it comes to path selection. And I'll even demo it for you so you guys can see what it looks like. But if you have a delta between my routing or my link state database and yours, you're still going to form a full adjacency. You're still going to do a full database exchange, except for when the databases are compared to each other, there's going to be a delta and it won't run. And it won't run on either side because the databases that are being exchanged don't line up. And it's not until you change the network type or fix the database error that it will be like, oh, okay, we're the same type of database. We are the same information being exchanged between each other. Because it's like a sanity check, right? You're checking against their sequence numbers that are sent back and forth and stuff like that to make sure that things are being done correctly. So we'll take a look at exactly how that comes into play as well. It is standards-based, can run between two different vendors. It's got large scalability. There is hierarchy through areas and topology summarization. So we'll take a look at what that looks like through using Area 0, Area 1, Area 2, etc. Then we'll do topology summarization. We'll do inter-area summarization and take a look at, actually that's how, when you get into inter-area summarization, you type and you do, summary, address, blah, 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 and you're trying to summarize from Area 0 to Area 1, for example, that's when OSPF starts to act like a link state or a distance vector routing protocol like EIGRP, because you're having to trust what that router is advertising to you because you don't have visibility into that environment. And that's where anything south of this is going to be where OSPF gets more complicated, because once you start doing hierarchical OSPF with different areas, you start adding in messing around with bandwidth and doing path selection and traffic engineering. Things get a little bit more interesting when you start diving into that. It does pass convergence, so it tracks active neighbors, and it does event-driven incremental updates, or what they call ISPF, or incremental SPF. So it will, instead of doing a full flood all the time, if there's a small change in the network, OSPF will detect that and only run an ISPF, an incremental shortest path first run on the newly learned LSAs, and go and do the updates that way. So it does provide efficient updating. OSPF does have its own IP protocol. So I literally said protocol twice. It uses reliable multicast and unicast. So multicast, just like EIGRP, it does multicast to go out and discover other OSPF speakers and to send updates. And then it does, once you discover it, and then you'll use unicast in order to actually send updates between two different OSPF neighbors. Non-OSPF devices do not need to process updates. So if you potentially could see something happening in the network, you're just not going to participate in that. Bandwidth-based cost metric. So more flexible than a static hop count like with RIP. However, the drawback to that is it's bandwidth-based. So like EIGRP, when you are doing your calculation, you're going to, unlike EIGRP, it does do the inverse, meaning where it's going to find there's a reference bandwidth as a default, and the reference bandwidth, I believe, actually let me pull up the CLI real quick. I don't remember off the top of my head what the reference bandwidth is. Let me minimize that. 26. So let me look at 26. Oh, I don't have OSPF turned on yet. So you're going to have the reference bandwidth, which I think is, so it's going to be 100 megabits per second. It's going to be a cost of 1. That's what the value is going to be. So if all of your links are gigabit or higher, you're going to want to change the reference bandwidth on a per router basis. And what that does is, unlike EIGRP's K values where they have to be across the board the same, you can have the reference bandwidth being a different value. I don't recommend that, but it's how OSPF will calculate the cost based off the bandwidth. So the simple thing is, if 1 gigabit per second is going to be your cost of 1, so it's a 1 to 1,000, not a ratio, but it's a 1 is equal to 1,000, so 1 gigabit is a cost of 1. So if I have a 100 meg link, that's going to be 10 times slower, so it's going to give you a cost of 10. And then if you've got a 10 meg link, that's going to be a cost of 1,000. So you'll see this when we get into that, because I'll go in and make some adjustments, and we'll see what the cost is. And you can adjust the cost based off at the interface level as well. I don't know how good it's going to be on these virtual routers. They usually don't deal with bandwidth very well. So we'll take a look at that in more detail when we get there, but that's essentially where that comes into play. But that's where the bandwidth-based cost comes into play. So if you've got, let's say, you're 10 gig everywhere, or you're 40 gig everywhere, or you're 40 gig in a particular area, you would want to set your reference bandwidth for the routers that are going to be able to calculate 40 gig. And then you can set the reference bandwidth to be something else. They recommend it being across the board the same so that OSPF calculates the same. But that isn't always the case. There are going to be scenarios where you've got, some boxes are doing 10 gig, all 10 gig. Other boxes are doing a combination of 10 and 1 gig, like a distribution switch or an access layer switch might have, more specifically probably an access or a distribution layer switch, where you're going to have, from distribution up to the core, you're probably going to have 10 gig or 40 gig or something like that, and your SPIs will be 1 gig, which will give them a cost of, if you're doing 10 gig as your base metric as your reference bandwidth, you would set your reference bandwidth to be 10,000 for 10 gig, and then for 1 gig interfaces you'd be a cost of 10. So if you had a 1 gig link between a couple of boxes, then obviously that would be a higher cost and less preferred path. And that's how OSPF figures it out, is based off of the lowest cost from point A to point B. Control plane security supports multiple forms of authentication. So we can do for OSPF version 2, I think it's um, clear text, so type 1. MD5 is type 2 because it's a hashed password. And and it's in OSPF v3 where you can do SHA and IPsec using an SPI. So we'll take a look at that when we get into v3 deployments and getting into all the cool stuff that goes along with that. There are some capabilities in there you're going to want to be aware of. So, and we'll stand up a v3 IPsec VPN. So, but think of it like a point-to-point IPsec VPN between your OSPF-enabled routers on a per interface basis. Now, the key thing is with that, and I'll go back into it once we get there, is you need a different SPI, security parameter index, per interface. So you can't have the same SPI per bot or per interface. You need some way to differentiate your interfaces from incoming traffic. So the SPI will be able to map the traffic to a particular process ID, and it'll be able to let OSPF know on a particular interface that you have an incoming control plane packet that's been encrypted. It is extensible, meaning that you can use OSPF if you are dealing with MPLS traffic engineering. Now, I'll be honest with you, there are much better ways to do it now. Ironically, though, the way that a lot of service providers are doing MPLS traffic engineering today they're not actually doing MPLS anymore. They're dealing with segment routing. And segment routing, if you wanted to do MPLS traffic engineering on traditional iOS, or like XR or iOS XE, like an ASR 1000 series router, an iOS XR, an ASR 9K, something like that. Well, you can do traditional MPLS traffic engineering tunnels, whether it's with active tunnels or whatever the case might be. But when you do that, you're relying on RSVP to figure out what the actual interface bandwidth is, and do to actually reserve the MPLS TE labels that you're going to need. And all of that is done through opaque LSAs type LSA type 10 with OSPF. So you can do traffic engineering. I'm not really going to be showing you any of that in this series because it goes way outside of the scope of even the layer 3 VPN capability. But for any time we would deal with like a service provider side, so which I'm looking at doing once I've got enterprise out of the way, circling back and doing some SP specific content. But one way or the other, you got this OSPF type 10 LSA that allows you to propagate traffic engineering information through OSPF and allow that capability. Because in order for you to do it, you have to turn MPLS traffic engineering tunnel or MPLS traffic engineering on at the OSPF level, or the process level, in order for the capability to come into play. So that is pretty much the high-level introduction to OSPF. I know I went a little bit deeper in some topics and stuff like that, but you're going to see the stuff as we get more into the weeds on anyway. So the more times you hear it, the better, in my opinion. So if you guys have any questions on anything, please leave a comment in the comment section below. If you haven't already done so, please like, share, and subscribe. And I'll catch all of you cool people in the next video.